Let's look at a couple more examples for the equation of a tangent line to a curve. Okay, remember a curve is not necessarily a function, it is simply a drawing in space. And our point of tangency is right there. And here is our curve. Our curve is an equation. And notice that the exponent on a y here consists of y to the fourth. And because of that, this is actually an implicit equation. So when we differentiate this, we'll also differentiate this implicitly. So we'll go ahead and do that. Let's differentiate implicitly. Remember, y is a function of x, so we're going to differentiate with respect to x. And notice x squared times y is called a product, so we're going to use the product rule here. Along with the chain rule, whenever we have to implicit differentiate a y that is beyond the exponent of 1. So I'm going to go ahead and do the product rule here. I'm going to do the derivative of the first function with respect to x. And then eventually we'll differentiate the second function with respect to x. So that will be the derivative of y with respect to x. Now when we differentiate y to the fourth power, we're going to differentiate this implicitly. So we're going to need the chain rule. So the derivative of the outside function evaluated at the inside function simply be this. And then remember to decrease the power by 1 times the derivative of the inside function. So dy dx. Derivative of 1 with respect to x is 0. And now we're ready to solve for dy dx. From here on out, it's just algebra. You just got to be really good at your algebra. You want to master it, be very confident with it, and then you'll be all right. You'll do fine. All right, we're ready to find the slope of the tangent line. So let's change procedures here. Let's evaluate the slope of the tangent line at the point of tangency. So x is -1. Put this over 4 times 1 to the third power minus -1 quantity squared. Simplifies to be 2/3 I should say. And now we're ready to find the equation of the tangent line. Just got to remember x1, y1 is equal to -1, 1. And like I said, most of this is algebra. Be very, very good at it. Be very confident at it. And then you'll be all right. 2/3 add 3/3, you get 5/3. There's the equation of the tangent line. And notice the slope is actually positive. So that is what we were hoping for and what you were hoping for from the picture that was given. Let's try a different function or a different equation which symbolizes a different curve. So this is a slightly different curve. It's slanted, and then we're looking for the equation of the tangent line right there, and then that is the equation of the curve here. Now, even though all the exponents of y here is 1, but y is actually composed inside another function. So this is also an example of an implicit equation, because notice y is not solved by itself. It's not isolated by itself. There's y here, and they're living inside other functions. So we'll go ahead and implicit differentiate this equation as well. So we're going to take the derivative with respect to x, okay, of that given equation. You are going to have to do some chain rules here because you can see y is living inside another function. Derivative cosine with respect to x, and then apply the chain rule. So the derivative of the inside function with respect to x is going to be 1 subtract dy dx. The rest of this is algebra. Solve for dy dx. And we are making the assumption that the denominator can never be 0, and that's why it allows us to find the slope to the tangent line of this curve. Let's go ahead and change procedures. Let's find the slope of the tangent line at the point of tangency. Now you do need to know your trig here. And with practice, you are mastering a lot of your trigonometry experience. Pi over 2 minus pi over 4 is simply pi over 4. So all the arguments here are pi over 4. So you just need to know your trig values. Notice we would get 1/2. Ready to find the equation of the tangent line. Once again, be very confident with your algebra and you'll be all right. And that's it. Notice the slope is positive 1/2, and it does match your intuition there of a positive slope in the picture.